So let's do one more example on this. So if I start off with 600 bacteria, and if they're dying off at a rate of 20% per hour, okay? So again, let me just kind of give you a picture of what's going on there. Okay, so we start off with 600 bacteria, and they're dying off like this. This is exponential decay. And so it says that 20% an hour, so I'm saying, 1 hour later, I will have reduced that by 20%, whatever that number is, okay? So our first goal is to come up with an equation. So we have a percentage, which would put us into one of these two here, right? These would be if you double or triple or something like that. So it's going to put us in one of these two. This one is like if we're compounding monthly or something, which is not the case. But what we have here is decreasing 20% per hour. So in fact, the n in this case would just be 1. Okay. All right, so we're going to grab this equation right here. So we have y equals 600 bacteria is what we start with. 1. And we're going to use a minus here since we're decreasing, they're dying off. How fast? The rate is 20%, so I'll put in my 0.2 here. Raised to the power of t, we don't know that yet, divided by n, but n is per hour, so it's really just 1. Okay. All right, so there's our equation. Or actually, I can go one step further. I could also say 600 times 0.8 t, so maybe that would be a better form of our equation. So how many will we have at 10 hours? Okay, so in other words, when t equals 10, how many bacteria will we have left? So we just need to plug it right into there. 600 times 0.8 raised to the power of 10. And you should be able to put that straight into your calculator and get 64. And I rounded up to the nearest bacteria, okay? So we're going to have 64 bacteria after 10 hours. Okay, and then how long would it take? So let's see. What would T be until we get down, clear down to just 4 little bacteria left? We've almost got rid of whatever that is, okay? So we're going to come back to this equation right here. So I'm going to grab this. I have y equals 600 times 0.8 t. But actually, in this case now, we want to know how long it's going to take until we get down to 4. So I'll put my 4 right there. And so as you can imagine, the first step would be just to divide by the 600. And that'll give us 0.0061, excuse me, 6667. I think that's what that is, okay? And then over here we're going to have, of course, our 0.8 raised to the power of t. Again, now to get our exponent here, we'd need to either take the log of both sides or the natural log. And so this time I'm going to choose to take the natural log. There's no advantage. I just want to show you that both work, okay? So then the natural log of that will give me negative 5.0106. And of course over here, the reason we did that is we can bring our variable t in front. The natural log of 0.8 is negative 0.22314. And of course, I just divide by that on both sides. Divide by the negative 0.22314. And that gives us then that t is equal to 22.45 hours. You could probably even round that a little bit more. All right, hope that helps you.